Hey guys, so for this lesson, I don't know if you saw my post, but the original printout I made of the package did not include these two pages, the next two pages. So I've reprinted them. I've also re-uploaded the PDF. You're going to need these next two pages because we're going to do a couple examples on them that are going to be really useful. So you can either come to class and pick these up, as my post said, or you can print them off yourself, or just do them on a separate sheet of paper, whatever works for you. So here we go. Advanced inclines. Basically, when I say advanced inclines, all I mean is that we're going to take our existing inclines, the problems that I looked at in the previous lesson, and we're going to add a few things to them. We're going to add tension. We're going to add multiple frictions. We're going to add some pulleys, etc., things like that. So here we go. Example 1, how much force is required to pull this mass up the frictionless ramp at constant speed? So what does it actually mean? We want constant speed, and we're told that the ramp is frictionless. So on a frictionless ramp, mu equals 0, and at constant speed, acceleration equals 0. So those are the two implications from the question that we got to remember. Now let's draw our free body diagram of our block and see what that, that gives us. So we've got a force of gravity, Fg straight downwards. We've got Fn perpendicular to the surface. And we've got force of tension. That's it. There is no friction, so there is no friction force to draw. Let's keep going here. Components for Fg. There's Fg parallel, Fg perpendicular. Fg is 7 times 9.8, which is going to equal 68.6 newtons. Fg parallel is going to be Fg, that's 90, this is 40 degrees. So this is going to be 68.6 sine 40. So that's going to equal 44.1 newtons. This guy is going to equal 68.6 cos 40. So that's going to equal 52.55 newtons. So if our perpendicular force is 55, or perpendicular component rather of gravity is 52.55, that means our Fn is 52.55. We've got our free body diagram. What we're looking for here is Ft, so we're going to start this the way we do all of the rest of these, with F net equals ma. Oh, I forgot one more thing. I have to draw on the diagram which direction I want to be positive, which direction I want to be negative. Doesn't really matter. We're looking for this force, though, so I'm going to call that direction positive. Doesn't matter which one you choose. Just have to choose one and remain consistent. So the only forces acting in the direction of motion of our block are this tension force and this parallel component of gravity. We said up was positive, so this is going to be Ft minus Fg parallel equals ma. Ft minus 44.1 equals 7 times 0. Constant speed means this thing is not accelerating. So this whole side is 0. So I'm going to get Ft equals 44.1 newtons. So I'm just going to add the tension, add the 44.1 over to the other side, and I find out that my tension force is going to be equal to the parallel component of gravity, which we could have seen had we talked about this a little bit further without jumping straight into it. But this is what it looks like mathematically. Okay? Relatively straightforward. Next example. We've got something that looks like this. We don't know what the masses are. We just know that one mass is little m and one mass is big M. We want to figure out which way this system moves. So we're going to add, we're going to draw the free body diagrams for both these blocks. We're going to add the forces to everything. Starting from the left, we're going to have Fg equals little mg, and upwards we're going to have a force of tension. On this block here, we're going to have a force of tension up this way. This thing doesn't say anything about friction, so we're not going to include it for the time being. We're going to have a normal force up this way and a force of gravity straight down. This guy here is going to be Fg equals big M little g. And now, like always, we're going to draw the component triangle for gravity. This is Fg perpendicular. This is Fg parallel. This is going to be equal to big M little g sine theta. This is going to be big M little g cos theta. And so we can see at this point we've drawn everything we can. Now we've got two scenarios. First of all, let's assume there is no friction. If there is no friction, then the only things that we have to consider are the things that are going to make this block move up and down, and this block move with the incline. Now my FTs are equal and opposite for both, so they're going to cancel themselves out. So basically what we've got here is we've got this Fg pulling down this way, and we've got the parallel component of gravity pulling down this way. So what we're going to have to consider in this case is a comparison, or we're going to compare little mg and big mg sine theta. The greater will control direction of motion. Okay. Without friction, it's relatively simple. If we have friction, though, so mu is not equal to 0. We can't add friction yet because we don't know what's going on here, but if mg is larger than big mg sine theta, that means it's going to want to slide this way. We don't know if it actually will because friction acts down the incline, opposing the direction of motion of this block. Okay? Conversely, we could have mg is less than big mg sine theta. If that's the case, friction will act up the incline. We'd have to then add friction and see if this thing actually moves. Okay? So we're not actually going to do, now we are actually going to go do exactly that problem. So flip the page. This is one of the examples that you wouldn't have had you not looked at the, what's the word I'm looking for? Oh, right. Had you not looked at the post, you wouldn't have seen that you're missing some pages here. So if you're missing this example, you're going to need it. Otherwise, you can just draw it on some blank piece of paper. Here we go. We want to find the acceleration of the system. Free body diagram. It'd be an Fg down there. It's mg, so 5 times 9.8. I'm just going to put a value there, 49 newtons. There's a tension force acting upwards here. So Ft. This guy has a tension force acting up this way. Ft. This guy has an Fn acting that way, and an Fg acting that way. The Fg there is going to be 8 times 9.8, which is 78.4 newtons. I don't know which way gravity is acting, but we do know that there is gravity. So we need the component triangle first. That's 90. That's 30 degrees. So my FG parallel is going to be 78.4 sine 30, which is 39.2 newtons. FG perpendicular is going to be 78.4 cos 30, so I'm just going to put that value here. That's 67.9 newtons. And so now based on this, we can actually see which way the friction is going to act. This force is larger than this component force. So the object is going to want to slide this way, which means friction is going to act down this way. Okay? So the force of friction is equal to mu Fn. Fn is equal to 67.9 newtons, which means mu Fn is going to be 0.05 times 67.9. So that's going to equal 3.4 newtons. Oh, sorry, a little bit. And I'm going to call, because this is going to determine if this thing moves, if this is bigger, the only way this object, the system of objects can move is up and over. So I'm going to call this direction, up and over the pulley, positive. So now we can go through and we can start our F net equals MA. We've got a pulley and two blocks. So we're going to have to bring together what we did in the previous, the review of what you did last year. Two equations for both blocks, add them together, and we're done. Well, it's almost, basically done. So one, I'm going to call this block 1, I'll call this block 2. This guy here, up and over and down is positive, so I'm going to have 49 minus Ft equals 5A. Block 2, I'm going to have Ft is acting positively, minus 3.4 minus 39.2 equals 8A. My FTs are going to cancel, and I'm going to get 49 minus 3.4 minus 39.2 equals 13A. I sum this up, so I'm going to get 6.4 equals 13A, when we're going to find that the acceleration is 0.492 meters per second squared. And it's positive, which is what we expected, so it's accelerating like this. And we're done. Just like what we did before, but now the force diagrams get a little bit more complicated, that's all. Flip the page. We're going to do, a couple more examples here. How could you determine, so let's say we add in this kind of force. Just quickly drawing a free body diagram. There's no mention of friction, so we're just going to have Fg downwards. Let's put Fn on there. Gravity is going to have its components, Fg parallel and Fg perpendicular. But this push force, which we're going to call an applied force here, just like gravity had to be broken up into parallel and perpendicular, components of the incline, so does this guy. We're going to need a perpendicular component, and we're going to need a parallel component. This is going to be FA perpendicular, and we're going to call this guy FA parallel. This angle right here was theta, and through a similar argument, I could prove to you that that angle there is also theta. If you want to see that proof, let me know. But that angle in there is going to equal that angle in there, which is going to equal that angle in there. So then what we have to do to determine the system, or the direction of the system, is compare FG parallel with FA parallel. The larger will determine direction of motion. Because those are the only two pieces of forces acting in the direction of in the plane of motion or the direction of motion, up or down the incline. One more kind of example, doesn't have any values in it. You're going to do an example with values in it in the homework. We're going to look at this. There is friction here. There's a value for mu. We're not told that there's multiple, so we're going to assume that the value for mu on this incline is the same as the value of mu on this incline. And we're just gonna go for it. We're going to label all of our forces, and we're going to see what happens. So we're going to assume we're finding the expression for the acceleration of gravity, assuming that m2 accelerates down the ramp and m1 up the ramp. So we're going to call this direction is going to be positive. So we're going to have Fg1, Fn1. We're told to assume that m2 is accelerating down the ramp and m1 up. So if m1 is going up the ramp, if that's my direction of motion and there is friction, friction has to be opposing that. Force of friction on 1. We also know that there's a force tension here. And that's the free body diagram for that. Now, free body diagram from this guy, there's going to be a force tension for the rope acting that way. They are the same, so I'm going to label them the same because it's the same rope. This guy here is there's going to be an Fn2 perpendicular to my incline. We're going to have gravity acting straight down, Fg2. And this guy's actually going to have friction. We're told that m2 is accelerating down the ramp, so friction is going to be going that way, up the ramp. Force of friction 2. So those are my free body diagrams. Now I can draw my component triangles. That's going to be Fg1 perpendicular. There's going to be Fg1 parallel. I'm going to have Fg2 perpendicular, Fg2 parallel. And now we can find the acceleration of our system. We've got 2 blocks. They're already labeled M1 and M2. So we're going to start with Fnet equals MA. We don't have any values, but that's okay. Block 1. Actually, I'm going to put some stuff in here. This is going to be Fg1 cos 30. This is going to be Fg1 sine 30. This one is going to be Fg2 cos 50. And this guy is going to be Fg2 sine 50. So now for our first block M1, if up and over is positive, we're going to have Ft minus force of friction for 1 minus Fg1 parallel equals M1A. This next one is going to, up and over and down is positive. This is going to be Fg2 parallel minus force of friction 2 minus force of tension equals M2A. We could add those together, but I'm just going to say dot, dot, dot. We would proceed like we would have before. Nothing has changed. The only things that are getting more complex is the way that we're, like the amount of forces, and we just got to make sure we keep track of all of those. So if you work your way through these things slowly, there will be no issue here. I'm not going to go take this example any further. We could put in that Fn is equal to Fg1 cos 30, and then this is going to be mu Fg1 cos 30. We could fill all of this in, get one really nasty expression for this system, and be done with it. But I don't think you want to do that, and I don't particularly want to either. But this is the setup that you're going to see for the questions that you're going to do for homework. So if you go back and look at the booklet that I printed out for you, they do have these pages in them. The homework that I want you to take a look at here is I want you to do question number 1. I want you to do question number 3. I want you to do 5. I want you to take a look at 6. And I want you to take a look at 8. Good luck. Comments, questions, concerns, as always, please ask. Let me know if you've got specific questions. The more specific you can get, the easier it is for me to help you, especially since it's all online. If you can give me specific things to help you with, that would be great. Good luck.